Hello, everyone. Can you hear me? Hello, everyone. Can you hear me? Thank you. Good evening to all of you. Today, I will not take more than 20-25 minutes, maybe 30 minutes maximum. So this is module number 6, and we are going to talk about regression analysis. And this is simple regression. Hope you can see my screen. Okay. So what is simple regression? Basically, there are two variables. One is dependent, another is independent, or one is cause, another is effect. So basically, what is the cause and what is the effect? So regression is basically, simple regression is based on one dependent variable and one independent variable. So directly I'm going here in my mini tab. Can you see my mini tab? Yeah, I think. Okay, so I'm just taking exactly the same data that we have worked in, I think, last weeks. So here you can first, very important thing to understand which is dependent and which is independent. So chance of admission is dependent, and these are all independent variables. So I'm just going to check one independent and one dependent variable. So first thing first, let me plot the graph, scatter plot, and let me go with this. And first by variable is chance of admission, and X variable is, okay, now I'm just going to other way. Okay, now you can see this is a simple plot, and now I'm going to make some fit line. So for example, this fit line is going to be like this. Okay, this is a fit line, best fit line. Then this part, is called intercept. Okay, and maybe denoted by, let's say, A. So this is A. Now I put 2 points at any place on this line. So for example, this is 1, this is 2. And what I do, I just draw perpendicular and horizontal lines with these 2 lines, and I can see. So you can see this is difference in Y. This is difference in X. So I need to get a slope, and slope can be del by or difference in Y upon del X, which is difference in X. So this is also known as gradient slope. Now, what is the equation of this line? Y equal to A plus BX. In other words, I would say Y equal to chance of admission. Chance of admission, I'm just writing in this simple term. Chance of admission equal to A is intercept, which is intercept and whatever value is, like I can write here is 0.4. 0.4 is intercept value, plus B is a slope. So this B, let's say I'm writing, some 0.2 or something, if I calculate, okay, I can do it here. From here, it is almost 0.2 divided by how much is this? This is 310 to 325, which is, I can write here like 15 or 13, 312 to 325. So I can write this is this, and then ZRE. So this is my equation. This is my equation. Now I want to check. What would be the value of what would be chance of admission if my GRE is like 309. So what I can do, I can predict, I can forecast based on this equation. I can forecast the value, or I can forecast the chance of admission. So based on this, I can see what are the chance of admission if my GRE score is 309. So this is simple regression. That means one dependent variable, one independent variable. And it is very simple. So first thing first, how do we start this? If you understand the concept of theoretical aspect, I'm going with more example, or more calculations using Minitab. So is it clear to everyone what we are going to do? Is it making sense? Okay, thanks. Now I'm just going to erase this. So basically, first thing first, to check the relationship between dependent and independent variables, which means two variables. So how we can see, first is a scatter plot. After that, you go under this statistics, basic statistics. Under this, you have correlation, and I'm going to check this chance of admission and GRE. And here we have option pairwise correlation table. Okay. And why we are going? Because we can get the p-value. P-value to check what we check here. So can you see? Here is a p-value is 0. And this is our plot, and this is R is 81. Means there is a 80%, 81% relationship between GRE score and chance of admission. Whether this relationship is significant, we can see the using p-value. Now, the null hypothesis for correlation is, can you see, this is H0, rho equal to 0, and H1, rho not equal to 0. So means, again, we are in inferential statistics. R is referred for sample, and rho is referred for population. So based on this sample, 500 sample, we are generalizing the the rho of entire all the students correlation, all 22,000 population correlation between chance of admission and GRE is significant or not. So null hypothesis says rho equal to 0, alternative says not 0. Means correlation is 0, or correlation is 0 means there is no relationship between GRE score and chance of admission. And alternative says there is a not 0, means there is some relationship between chance of admission and GRE score. So basically what we need this in order to see there is some relationship. If this is clear, we are going further. Now, please look into this. What do you say? Now there is a relationship. What is the meaning of this p-value? What is the significance of this p-value? Or I would say this is in terms of word, useless, or I would say this is useful. Useful. What do you say? What do you conclude? So basically, p-value is less than alpha. P is less than alpha value. That means null hypothesis is rejected. Means useless is rejected, and then we can say this correlation is useful. That means this 80, there is a useful correlation between chance of admission and GRE score. If this is making sense, is it making sense? So yeah, so basically this is first thing first to check whether the correlation is correct or not. So correlation, I mean, I already explained this, rho equal to 0, rho equal to not 0. After, you know, because we get all these statistics in you know, this, therefore I'm not talking about this. Now, simple regression, I already explained that y equal to slope into, you know, independent variables plus intercept, which we did, you know, intercept plus slope into x. So, you know, they did in different way. So basically, these are the interpretation of regression model. Sales equal to 268 plus, so this is intercept plus this is slope and advertisement. So each extra $1 million of advertising will generate 7.37 million of sales. How? Look into that. On an average, the firm would average, means if you put 1 million, that will be this, and this remain constant throughout this. If ad spending is 0, means this would be the only value. Similarly, you know, this dependence and drug cost in, so if you know, so this is the meaning. If I put, you know, advertising by 2 million, then how much total would be? 7.737 into 2, which is almost 14.5 million plus 268 million. Means even if you don't put, if you put 0 money in advertising, then you will get this much sales. Means if you increase this advertisement by 1 million, you are going to have this much. Very simple. If you don't spend any single money, then your sales is 268. If you are going to spend 1 million, it is going to compound and multiply by 7.37 plus this. If you are going to spend 2 million, 14.5, and keep going on. So this is a simple interpretation based on that. Is it making sense? If yes, you can see this. If the firm spent $10 million on advertising, its predicting sales would be 314.7 million. 268 plus 7.37 multiplied by 10, which is this much. Similarly, rent would be 150 plus 1.05 square feet. That means 800 square feet apartment, 150 plus 1 point, which is $990. So basically, you know, also you can check the apartment rent, housing prices, you know, normally, you know, housing prices is a very good example. the square feet and related prices. So this is the importance. So basically, this is another explanation, which is this is the cause and this is the effect. So basically, this is also known, regression is also known as causal relationship or causal. So because this is a cause, you have $2 million of spending in advertisement and the sales is going by this much. So this is cause, this is effect. Now, cause and effect models and, so different thing. So basically we are just going on few things here, and then rest of the things we will cover in, following course. So just I'm going to use this. So if this is clear, let's do. So correlation is fine. Now I'm going to do regression. Statistics, basic is this regression and fit regression model. What option do we need to choose? Automatically it will select best option, which is ordinary least square. Why it is known as ordinary least square, that I'm also going to explain. So response mean dependent variable. Here we have chance of admission. Continuous variable is this. Categorical variables, like here we have research, yes, no. Categorical variable is university rating. We have 5 categories or 5 level of rating. So there we can use this categorical predictor, or you can put here also. Here we have different options, and under this different option, here you need to do one more thing, which is store. Here you have all the residual and all. So you just select these two things. Why we are? Because we are going to make some yeah. And we have also one thing which is called Darwin-Watson test. So option results Darwin-Watson test. However, I don't have questions in assignment and fill in the blank about that, but just showing so that it is easy for you to learn in next class. Okay, now we got all the options. I'm going to make it bigger. So look into chance of admission is minus. So this is our intercept. And this is our slope. So we got the equation. We got the chance of admission. Now I have, let's say, GRE score of like 320, 340, whatever, I can get to know what are my chance of admission. If this is done, now we go to further thing. Here we have two constants. One is, this constant, and this is a slope. So you can see clearly, this is this, and this is this. Now, whether the null hypothesis related to constant. So H0 is constant, or I can write in different simple wording, which is, I can say like intercept, just this is cancel. Intercept. So null hypothesis, intercept equal to 0. Alternative hypothesis, intercept not 0. Similarly, another null hypothesis, slope is 0. Alternative is slope is not 0. Or in other words, I can say this is useless and this is useful. Similarly, this is useless, this is useful. So these are now we would like to check in this model whether this is useful or useless, whether the slope is useful or useless. Now, since you know p-value, this is p-value, tell me whether this is useful or useless. Tell me in this model, this slope is useful or useless. I'm just erasing this part. So yes, tell me. In this model, is this useful or not? Is this useful or not? And these are the p-values. For constant, this p-value is 0. For GRE score, this is slope is 0. P-value is 0, sorry.
Is it yes because they don't equal 0?
Yes. So, in both cases, null hypotheses are rejected. Alternative are accepted, means this is also this is also useful in this model, and this is also useful in this model. I will also demonstrate the case where these are not useful. Or let me go and do one thing. So let's do the same thing. No, we'll do later, because this will be one more thing here. You can just check it. This is coefficient, this is standard error of coefficient, and this is t-value. What is the significance of this? GRE, this is t-value. There is a relationship between this, and this. How? This multiplied with, just a minute. So, I just use my calculator. So 2.483 divided by 0.104, and you can get, this is the 23.875 is the answer. So this is the relationship between this. Coefficient divided by standard error of coefficient equal to t-value. So I did not put the negative sign, but you can do, if I have negative 2.483 divided by 0.104, and you can get this t-value. So you can understand, get the relationship, this divided by this equal to this. Similarly, we can do for this C. 0.01126. No, I think I write 0.01012 divided by 0.000 3 times 328.
Okay.
Can you see this is 30? I mean, are you able to see my calculator, which is on the top, on the top of mini tab?
Yes, we see it.
Yeah, so this is 30. So this is the relationship VIF. It is called variance inflation factor. Variance inflation factor, one means it is used for multi-collinearity. So in simple regression, it does not have that importance, but it has in multiple regression, VIF, variance inflation factor. So we are not using as of now, but this is, so these are the thing. Now we come to model. So this is a standard error of model. This is R square. This is adjusted R square. This is R square. So basically we are going to check these two things. R square means what is the, and this is adjusted. So R square means, just I'm going to say R square. This is called regression or coefficient of determination, or also regression factor or regression coefficient of determination it is called. So 65.67, how do we interpret this? 65.67 change in chance of admission is due to GRE. Means 65.67% chance of admission depend on GRE. So basically you can frame in different wording. However, chance of admission depend 65.67% on GRE score. This is simple meaning, but otherwise this is cause 65.67 cause is cause in chance of admission is due to GRE score. So different wording you can use based on. So let me go with slides wording. Yeah, this is called coefficient of determination. So you can often square R square. So basically R square value is between 0 to 1. And how do we? So basically when you read, you will see the wording. Simple is that 65.67% chance of admission depends on GRE score. Now let's go back to. So this is clear. What is R square adjusted? Actually, always, in model, R square and adjusted R square is given. This is little smaller than R square. So for example, here it's 0.67, this is 0.6. Always, this is more precise value of R square. Why? Because this R square eliminates, insignificant contribution of the numbers. So basically it eliminates unwanted numbers or errors or different thing. Therefore, this is more precise R square, or you can say this is filtered R square. How? I'm just going to, because these are unusual observation, means these numbers are not correct. How many? Like few of them out of 500 numbers, these numbers are looking like data error, or when we were entering data into or collecting data, or people have provided wrong data or whatever. So these data points, so when adjusted R square is calculated, these numbers are eliminated by system automatically, or some filtration has been done, which are totally unusual. Therefore, this is little less than R square. Now let's see what is the difference. We first calculated a small r. A small r we calculated. This is correlation. And this correlation starts from -1 to +1, and capital R, regression coefficient of determination is between 0 to 1. Now, what is the relationship? Let's do it here. This is a what is the correlation coefficient? 0.81. So 0.81 into 0.81, 0.6561. Do you see this? And actually this is our regression coefficient. So basically this, in simple regression, if you know the correlation, and you multiply R into R, you get regression coefficient here, coefficient of determination. So this is the relationship between correlation and regression in simple regression. But in multiple regression, this is not the case. So just remember until this, module, or, with this course. So we are good. Now let's go further. Here, this is regression. Whether your entire regression is valid, again, same concept. If H0, again, R square is significant or, useful, useless, sorry, here, useless, and then R square useful. Here. So what do you say now? P value for this is this. So basically, this R square is useful, means our model is whatever is useful. This is based on, now here, other things, GRE and, degree of freedom, other things. This is checking the ANOVA, analysis of variance. We will, now these are the unusual values in. Now let's look from naked eyes what it is saying. Let's say, we just go for 118th number of observation. Let me go with 100 number, 18 number. So we are going here. Can you see this? What it is saying? GRE is 219, TOEFL is 14, university rating 4, statement purpose and letter of recommendations are very. So we are just going based on this GRE and chance of admission. So 290 and chance of admission is 45. So this is unusual data, or, maybe error, or maybe someone gave wrong information, or you made an error. Similarly, I go with another, which is 378. So what is the job of data analytics? To go back to the person to correct the means get the input again. If error, correct it. Otherwise, usually what people do, they just remove these entries from the data, means they remove these numbers, or these, they don't count in the model when they do the modeling. 378. So here 378, GRE score is 290. And what is the chance of admission? Where is chance of admission? Yeah, 47%, means 0.47. In that case also, I think the same numbers were there. So maybe, also these numbers, let's say, let's check, the last one, which is 418. Look into 316 GRE. I think GRE is, and so and the chance of admission is 52%. I mean, this 0.5. So this is also, so there are many ways to, now where are the problems, where are the issues, unusual, which is unusual. So again, I go here. Now you can see, and this is our plot. You can see some numbers which are unusual here. Sorry, like this is unusual, these are unusual, this is unusual, they are not coming, this is unusual. Similarly, you can find some numbers, like here, these are unusual, which are, so here are also some unusual. So by naked eye, we can see. Now, what is the method, or ordinary least square? So basically, we do this thing. We try to make the best fit line that will have minimum distance from all of them. Means this is a best fit line that reduces the distance from each null, each point. Therefore, this is known as, or best fit line. And this method is known as ordinary least square. I'm not going into more detail about that. You just understand the interpretation. So yeah, this is regression. We just Darwin-Watson statistics is used when we do the time series data. Time series data means one x-axis is time, like let's say your salary or your income over the period of last 20 years. For example, I put here year, and here you put income, or your so from last 20 years you have been earning 30 years, and if you put the regression analysis by x-axis is year, and then Darwin-Watson test is important. So we are not talking as of now. Now what we have done, this residual and standardized so these so are these residuals are normally distributed or not? Why we are doing? So what is the residual? Basically, let's say we plotted this, this line, best fit line. So this distance, one would be positive. This distance from each number, from this distance, count, this distance, this is residual. So we would like to see whether these are normally distributed or not normally distributed. So we have, very simple thing, though that is not important in this module, but in next class or next BADM. So I have their graph, and here we have probability plot, and let's say okay, and residual, I just check the residual distribution, okay, and that data option. So basically I'm just, and now you can see. So this is basically by default it comes 95% residual minus to plus. Are they normally distributed and not normally distributed? So there is a p-value. So again, the H0 and H1 and H0, I think it has, or it doesn't have otherwise. So yeah, errors are normally distributed, errors are not normally distributed. So exactly the same. So errors are normally distributed, not normally distributed. And what is your based on p-value, you can tell whether they are distributed normally or they are not distributed normally. P-value is less than 0.005 value. Therefore, errors are not normally distributed. So what we are, and now one more important thing. So let's do, how we can do the forecast. Suppose this is the equation. Now how we can apply for our knowledge? GRE score. Okay. Let's say I got a GRE score 312. What would be my chance of admission? So I go under statistics, is regression, and predict. Let's say I have 312. Let's say I'm checking for 5 students or 3 students. Another got 314 and one got 290. What are the chance of admission of all 3 people? Let's look into that. So the person who got 312, their chance of admission is this 67.6%. Yeah, this is the prediction, this is the chance of admission, 67. Someone who got 314, chance of admission is 69%. Somebody who got 290, chance of admission 45%. So these are the prediction value. Now this is confidence interval and this is a prediction interval. So basically confidence interval is, based on this number, this is the true population and this is about predicting modeling. Predicting modeling is, this has wide range. Similarly, this is a predicting and this is a more precise confidence interval. This is prediction interval. So yeah, this is, but the prediction can only be done when you first, so for example, you are going to do this regression. First, you run the fit regression model. In second step, you do the prediction modeling because first you do this, then machine will understand this is going to be the model, and then it will do this thing. Now I'm going to show another case. So statistics, regression fit regression model. Instead of GRE, I'm just going to use a statement of purpose that everyone has to write. And this is the the model. This R square is 46, adjusted R square is 46.7. All the values are right here. And these are unusual, like we have seen. This model is fit or not? This model is correct or not? This is also p-value is less than this, means this is correct. This is also less than 0. Okay, this is 0, means this is also, the model is correct. This is regression is also this, means this model can also be used. This is valid model for predicting or estimating chance of admission based on a statement of purpose. Now I'm going to do a multiple regression for your just understanding. Sorry. Instead of, chance of admission and, now admission depend on multiple factor. So I'm just going to select. Okay, these all of them I'm going to select. Means because admission truly depend on GRE, English and CGPA. So now I go and do this thing. Now this is a model, multiple regression model, which is intercept. This is first slope of GRE. This is second slope, third, 4, 5. These are the slopes of different. Now in this model, whether which are the which items we can remove. Which are the items are not useful. So basically, if you look into the p-values, this p-value is more than this, and this p-value means they are useless. Useless. This is, these two items, which is university rating, and let's see how we can see that. Means because p-value, so in this model, this is going to be, now I'm going to see the prediction, whether this is correct or not. So let's say I'm going to do basic regression, regression predict. Now GRE is like 319, ZRE is 319. TOEFL is 122. 120 is maximum, so 108 and 108. University rating, so one I'm putting a 4 or 5 out of 5. Here I'm putting 0. A statement of purpose here 5 out of 5. Here I am putting 0. Letter of recommendation like 2 point or 4.2, 4.2 same. So everything else I'm putting a same. I think did be university or research. So CGPA is like 9.2, 9.2, and research, both are research university. So I put, the numbers, and now I'm going to estimate. Now look into that. This is the equation. I use first setting, this 319,108 university rating highest here. And in this case, I put university rating 0. Means 5 and 0, you can see how big difference is that. But whether that is making the difference in our chance of prediction, look into that. Here, when I have all 5, it is giving 83 or 84% chance of admission. However, when I made these two variables 0 in the equation, the chance of admission is 80%, means 3-4% only chance of admission put together is here. Means they are in model, they are not contributing, means chance of admission and a statement of purpose are, university rating and a statement of purpose are not contributing significantly in the model. Therefore, if you look into this, these two are not that important in predicting. If you score 0, means if you even don't submit these two things when you are applying, it will not affect your admission. Or, it doesn't matter how good letter you write for admission or your statement of purpose for admission, or how bad you write, it is useless in all the admissions. So this is about regression. I wanted to explain to all of you. How about, okay. Where is this? No. I think, yeah. Now look into, so this is where you are talking. How about 0.002? Do I have point? Yeah, this is okay, correct. So this is less than 5%. Alpha value is less than 5%. By default, this is running 95% confidence or 5%. So, so H0 is all constants are 0. H1 is all constant, not 0. Or again, I can say this is useless and this is useful. Sorry, please bear with useful. Now look into this. So by default, it is coming 95%. This is less than 1%, less than 1%, 0.2% only where we are running. So you know the theory about when we accept null hypothesis, when p value is greater than alpha value, then we accept null hypothesis, where this is. So in this case, we have in these two cases, we have accepted the null hypothesis. Therefore, what is the meaning of this? This means if this part means state this is 0, means whatever value you will put for a statement of purpose, this whole will be 0. That means this does not have any significance in this equation. Similarly, for university rating, if this is 0, then entire thing means these two are not playing importance or any significance in this chance of admission regression model. So this is less than this and we are happy. Anything, if even this is like 0.049, you can accept null hypo. Even 0.05, because this is just on the point. Even if it is clear, you will accept, you will reject the null hypothesis. Usually this is not the case, but if you will find here and there. So MD, is it clear to you? Okay, so this is what I wanted to explain to every one of you. Just, very simple example here. I can just demonstrate, which is nowadays, very hot in the market, which is housing prices. And for example, this is the price of the house, and this is a square feet. So based on a square feet. So what I'm going to do, I'm going to create a random data. So using integer, where is my integer? Right here. And I'm going to take us, 50 data points, 50 house prices. So I'm going to do store in column price. Minimum value housing price in South Hill is like 320,000. And maximum in my area is about 500,000. Okay. And I'm going to do the square feet also randomly, stat, calculate, and integer and a square feet. So here I just go square feet. Okay. And a square feet is like 900 square feet to 1800 square feet. Okay, so does price depend on a square feet? So let me run this model. So this is, number, randomly created using. So I go under regression, fit regression model. Now I go under, this is prices. Oh, sorry. Price is dependent variable, square feet is not. And I'm going to just do. Now look into that. Look into the model. Now, what do you interpret from this model? Because we have not done this. If you do yourself, you will get to know more. What is your interpretation? Doesn't matter. This does not matter. This is a, useless. Square feet is useless. The prices are about this in South Hill area. And so basically, because p-value is this, so you can understand null hypothesis, useless, useful. This is higher than this. This is useless. Means if you have 2000 square feet or 1000 square feet, you will not get, the price will not change much. Let's do, for example, 412,000 is this, suppose I have 500 square feet of a house and 1500 square feet of house. What would be the impact in the pricing? So I go under statistics, regression, predict, and I'm going to do this 500 square feet and 1500. So how big is the house? You are for 500 square feet, the price would be 415,000. And for 1500,000 square means you increasing 1,000, but you are only increasing like how much? 6,000, around $5,000, $5,000 for 1,000 square feet. Means this is square feet is insignificant, is useless. So basically this model is useless in order to predict this housing. But if you do, I mean, if you do, for example, Zillow, you go on Zillow.com. I mean, this is just for your own interest. You want to see the prices of your house or your house. What you do, just, you know, for example, this is, let's say 460,000 is the, how much area is there in this? I don't see area. Do I see area?
It's at the top by the price, 2674.
Okay, 2674, even still I can't see. Okay. Okay, so yeah, you can do the collection of like 50 houses in your area, and you just try to see, you know, whether the model is valid, and you can estimate the price based on square feet only. So yeah, you can do a lot of things. So this is about, you know, regression model. So if you have any question related to this, please let me know. I think I told you that I'm going to take 25, 20, 30 minutes, but it is almost an hour. Okay, so if no, then I would like to say have a good night. I already made an announcement. So this module is not going to be in an exam. And good luck. Bye-bye. See you in next course, which is BADM 520. Bye-bye.
Thank you.
Bye.